Welcome everybody! In this video, we will be solving a problem that will help us better understand modulo inverse. There is a fleet of 31 ships. Each ship has the same amount of people. There is fewer than 60 people on each ship. Everyone in the fleet is distributed equally into airplanes. Each airplane holds 83 people, but the last airplane only holds 59 people. What was the greatest amount of people that could be on each ship? Let's analyze this a little bit. We know there is 31 ships, and each ship has the same amount of people. And this amount of people is actually what we're trying to find in the problem. So we can call it x. This means that the total number of people can be represented as 31x. And we know that there has to be less than 60 people on each ship. Everyone in the fleet is distributed equally into another vehicle, which is airplanes. Each airplane can hold 83 people, but the last airplane only holds 59 people. This means that when we were trying to split everyone into airplanes and fill them up, the last airplane had 59 people left over. So when we write this as a congruence, it can be 31x is congruent to 59, that's the remainder, mod 83, because we're trying to split it into groups of 83. So now we're going to try to solve for x. In order to solve for x, we have to isolate it somehow on its own side of the congruence. In algebra, when we solve for a variable, let's say 5a equals 10, in order to solve, we have to multiply some sort of inverse on both sides in order to isolate the variable by itself to get the answer. So we're going to do a similar thing to our congruence in modular arithmetic. We're going to multiply some number, let's call it a bar, that will isolate x and let us be able to solve for x. So which means that when we multiply a prime on both sides, the 31 will disappear because we're trying to get rid of the 31 and isolate x. So x would then be congruent to 59 times this number, mod 83. This inverse, which is a prime, times 31 will have to be congruent to 1, mod 83. This is so that when we multiply a bar and 31, it basically just cancels out and becomes a 1. It doesn't really matter anymore. Now we're going to try to find what a bar is. First, we have to know that modulo inverse only exists if 31 and 83 in this case are coprime. And yes, we do confirm that 31 and 83 are coprime. This means that our modular inverse does exist. So we're going to go ahead and try to find it. We're going to use the Euclidean algorithm. 83 is equal to 31 times 2 plus 21. You have to be good at the Euclidean algorithm in order to solve for the inverse. Then 31 is equal to 21 times 1 plus 10. 21 is equal to 10 times 2 plus 1. And we can stop here because the next one, because when we keep writing the next equation, we're going to get a remainder of 0. Now, we're going to do something called linear combination. Let's see what this is all about. we're going to rewrite all of the remainders in terms of the other numbers. For example, 1 will become 21 minus 10 times 2. We are isolating the remainders. 10 is equal to 31 minus 21 times 1. And 21 is equal to 83 minus 31 times 2. Now what we're trying to do is rewrite our 1 in terms of 83 and 31. Well, why do you ask? Well, if 1 was written as 31 times some number plus 83 times some number, and we're basically just rewriting this congruence here, we would get something that looks like this. When we do this, because we're modding 83, the 83 term can get reduced, so we don't need it anymore. And we're left with something times 31 is congruent to something times 31 mod 83. So we can know what A equals then. A is equal to the coefficient of the 31 term. So this is why we're doing the linear combination. We're trying to rewrite 1 in terms of 31 and 83. So let's go ahead and do that. 1, we're going to start from this equation, is equal to 21 minus 10 times 2. 21 can be directly rewritten as 83 minus 31 times 2. And let's put parentheses around the 31s and the 83s to keep it clear. Minus 10 times 2. 10 can be rewritten as 31 minus 21 times 1 times 2. And this can be further made into terms of 83 and 31. 83 minus 2 times 31 minus 2 times 31 plus 2 times 21 is equal to 1. And we can combine like terms. 83 minus 4 times 31 plus 2 times 21. Well, this 21 can be rewritten in terms of 83 and 31. This is equal to 83 minus 31 times 2. We keep referencing what we have written here. So we keep simplifying. 83 minus 4 times 31 plus 2 times 83 minus 4 times 31. And then we're going to combine like terms for the last time. 3 83s minus 8 31s is equal to 1. So we have our final equation as a result of linear combination. Let's go back to our overarching congruence, which is this. A bar times 31 is congruent to, this time we're going to rewrite the 1. 3 times 83 minus 8 times 31, mod 83. Because we are dealing with mod 83, any term with a factor of 83 can be reduced. So we are left with 31 times a bar is congruent to negative 8 times 31 mod 83. Looking at this, we can see that a bar must be congruent to negative 8 mod 83. So we are very happy because we've solved what our modulo inverse is, a bar. We can make this a little bit more clear and not make it a negative number by adding 83 to it. So we would get 75. A bar is congruent to 75 mod 83. Now let's use it on our original problem. we have to multiply a bar on both sides of our original congruence. So our original congruence is 31x is congruent to 59 mod 83. Now we're going to multiply the modulo inverse of 31 on both sides, which would isolate the x and give us 59 times 75 mod 83. So I want you to pause the video now and solve for x. Great. Now let's actually do it together. X, in the end, when you reduce it and everything, you get 26 mod 83. Because you're going to get a really big number after multiplying these two numbers, but then you keep subtracting 83 from it until you get 26. So x is congruent to 26 mod 83 is our final answer. But the problem asks for what is the greatest amount of people? So what is the greatest value that x can be? And remember, x is less than 60. So x could equal 26, yes, but x can also equal 52. It's a multiple of 26. And 52 is the greatest number that x can be that is still less than 60. Which means that 52 is our final answer. 52 people were on each ship. And if we want, we could go back, take 52, substitute it into our original congruence, and then check our answer to see if it's correct. And for this problem, we first had to write out our problem's info using modular arithmetic. And then we used the Euclidean algorithm to help us find the modulo inverse. After using the Euclidean algorithm, we used a linear combination in order to rewrite our 1 in terms of 31 and 83. Because if we rewrite 1 like that, in the end we can reduce and isolate x. Thank you for watching this video. I hope you learned from it, and I'll see you in the next one.